The filling of electrons into the orbitals of an atom is governed by the Offball Principle, Paulis' Exclusion Principle, and Hund's rule of maximum multiplicity. Let us start with Offball Principle. Offbau is a German word which means building up or construction. Here, building up refers to the sequence in which the electrons enter into various atomic orbitals. This principle states that, in the ground state of the atoms, the orbitals are filled in the order of their increasing energies. This means that electrons first occupy the lowest energy orbitals available to them, and then enter into the higher energy orbitals successively. The order in which the various orbitals are filled is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, and so on. This order can be represented in the form of a diagram as shown here, in which the direction of arrows indicate the order of filling of the orbitals. This representation can be conveniently remembered. The energy of an orbital is determined by using the n plus L rule. According to this rule, the lower the value of n plus L for an orbital, the lower is its energy. If two orbitals have the same n plus L value, the orbital with lower value of n has lower energy and hence is filled first. For example, for 4s orbital, the value of n and L are 4 and 0 respectively. Hence, the n plus L value of 4 plus 0 equal to 4. For third orbital, the value of n and L are 3 and 2 respectively. Hence, the n plus L value is 3 plus 2 equal to 5. This shows that the 4s orbital will be filled first, as the 4s orbital has lower value of n plus L than the third orbital has. The orbitals 2p and 3s have same value of n plus L, which is 3. Now, as per the n plus L rule, the orbital with the lower value of n has lower energy and hence is filled first. Thus, 2p is filled first, followed by 3s. Let us observe the arrangement of orbitals up to 4p in increasing order in accordance to the n plus L rule in the following given table. Next, let us move on to Paulis' exclusion principle. Austrian scientist Wolfgang Pauli has put forward the principle called Paulis' exclusion principle. This exclusion principle provides certain restrictions for the number of electrons to be filled in various orbitals. The Paulis' exclusion principle states that no two electrons in an atom can have the same set of 4 quantum numbers. This principle can also be stated as only 2 electrons may exist in the same orbital and these electrons must have the opposite spin. This means that 2 electrons in an atom can have a maximum of 3 quantum numbers that are same with each other but not all the 4. Note that if one electron spins in clockwise direction, the other electron spins in anti-clockwise direction. Let us write the values of 4 set of quantum numbers for 2 electrons in 1s orbital. as shown here. The values of N, L, M and S for the first electron are 1, 0, 0 and plus half. The values for the second electron are 1, 0, 0 and minus half. This shows that the two electrons have the same values for N, L and M, but different values for S. This indicates that the maximum number of electrons that can be accommodated in an orbital is 2. Similarly, as P, D and F subshells have 3, 5 and 7 orbitals, they can have the maximum number of electrons equal to 6, 10 and 14 respectively. We know that the total number of subshells that can be present in a shell is equal to the value of n, which is the principal quantum number. This principle has an immense value as it gives the maximum number of electrons that can be accommodated in a shell, which is equal to 2n square. For example, if the value of n is 2, the total number of electrons can be calculated by substituting the value of n into n square, which is equal to 2 multiplied by 2 square, which is equal to 8. The third rule of filling of electrons into the orbitals was proposed by Friedrich Hund. It is called the Hund's rule of maximum multiplicity. This rule helps in filling of electrons into the orbitals of same subshell. The orbitals belonging to the same subshell have same energy and are called degenerate orbitals. The Hund's rule of maximum multiplicity states that in a set of degenerate orbitals, the orbitals are singly occupied first and then pairing of electrons takes place. It can also be stated as the pairing of electrons in the orbitals belonging to the same subshell doesn't take place until each orbital belonging to the same subshell gets one electron each. Therefore, electron pairing in P, D or F subshells cannot take place until each orbital of a given subshell contains one electron each. In other words, pairing of electrons in P, D and F subshells starts with the 4th, 6th and 8th electron respectively, as shown here. Also, all the singly occupied orbitals will have spins in the same direction. Moreover, it is observed that half-filled and completely filled subshells impart greater stability to atoms due to the symmetrical distribution of electrons. More detailed explanation on the cause of stability of half-filled and completely filled subshells will be learnt in the later part.